Okay, this video is on similar triangles, and it's specifically about how do you know if two triangles are similar. And there's a few different ways that you can answer this question, and we're going to take a look at 5 different ways you can answer this question. So the first way you can answer this question, how do you know if two triangles are similar? Well, if the problem tells you that they're similar. So very often you will get, for example, a problem that says, it may say actually in so many words, the two triangles below are similar. Or sometimes you don't actually get it in, in actually English language. Sometimes you might get, for example, a statement like this: triangle A, B, C, and then the little squiggly mark that means is similar to. Triangle ABC is similar to triangle JKL. All right, so if you've got either one of these two things in a problem, well then you know right away that two triangles are similar because the problem is telling you they are. Answer number 2, how do you know two triangles are similar? If all 3 pairs of sides are proportional, and all 3 pairs of angles are congruent. And we've seen this before. This is essentially the definition of congruent triangles. So, for example, if you happen to have a pair of triangles and you have markings on the triangles that indicate that all 3 pairs of sides are proportional and all 3 pairs of angles are congruent, then you know those two triangles are similar. So if I take a look at these two triangles here, the first thing I notice right away, I can tell that I've got my 3 pairs of angles that are congruent. So that's this pair of angles right here, this pair of angles right here, and this pair of angles right here. They have these same curvy hash marks that indicates that I've got 3 pairs of angles that are congruent. So this part I've got, the angles. All 3 pairs of sides are proportional. So if I want to see if all these sides are proportional, I'm going to have to actually set up the ratios between each of these pairs of corresponding sides and see if these ratios are all the same. If the ratios are all the same, then I know that all of the pairs of corresponding sides are proportional. So let's see. 7 and 49. So 7 to 49. Let's see, that will reduce to 1 over 7. Let's see, 6 over 42. Let's see, that will reduce to also 1 over 7. And then 5 over 35. So 5 goes into 5 once, 5 goes into 35 7 times. And I can see that each pair of corresponding sides here, they all give me the same ratio, which means that all of these pairs of sides, all 3 pairs of sides, are proportional. So since that's true and that's true, I can say, yes, these two triangles must be similar because all 3 pairs of sides are proportional and all 3 pairs of angles are congruent. So those first 2 answers, those are fairly straightforward. The next 3 answers are, it turns out that there are other ways that you can tell if two triangles are similar. In particular, you can say, how do you know if two triangles are similar? Well, if all 3 pairs of sides are proportional, in other words, if all you have is information that tells you the 3 pairs of sides are proportional, if that's all you have, you can still say that those two triangles are similar. For example, here I've got these 2 triangles, and this, I notice these are the same numbers for these pairs of corresponding sides as in the previous example. And I already know that since 7 over 49, that reduces to 1 over 7, 6 over 42 reduces to 1 over 7, and 5 over 35 reduces to 1 over 7. Well, then I know these triangles are similar. There's my little similarity symbol there. These triangles are similar because all 3 pairs of sides are proportional. So I would write that down. All 3 pairs of sides are proportional. By the way, this particular answer right here, the all 3 sides proportional, we sometimes write that using a kind of shorthand notation, which looks like this. S, 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 and then the little squiggly mark, and that just stands for side, side, side similarity. So if I wanted to answer this question, in a kind of shorthand way, how do I know that these two triangles are similar? I know these triangles are similar because of the side, side, side similarity theorem, it's called. So I can use that as a kind of a shorthand way of answering that question. Now, these two triangles, notice I would like to use this same answer. I'd like to be able to say that these two triangles are going to be similar because all three pairs of sides are proportional. But I notice that even though I've got this pair of sides, 7 over 49, that equals 1 over 7. And I've got this pair of sides, 5 over 35, which also equals 1 over 7. Notice that my other pair of sides, 6 over 40, well, let's see if I reduce that. That gives me, 2 into 6 3 times, 2 into 40 20 times. And that one is not equal to these other two. So therefore, I know that these two triangles are not similar because, and I could say, well, they're not similar because all three pairs of sides are not proportional. So all three pairs of sides not proportional. Now let's take a look at a fourth way that we can answer the question, how do I know if two triangles are similar? I know if two triangles are similar if two pairs of angles are congruent. In other words, even though I might not have any information at all about the lengths of the sides, if I have information that tells me that, for example, this pair of angles here are congruent, they're both 27 degrees, and this pair of angles here are congruent, they're both 31 degrees, well then I know that these two triangles here are similar because two pairs of angles are congruent. Notice that this answer right here is also often written using a shorthand notation. It's often written as A, and the little similarity symbol again that just stands for angle, angle, similarity. And so I could write this one, my answer to this one, if I didn't want to write out two pairs of angles are congruent, I could just write angle, angle, similarity. Notice that these two triangles here are also similar, even though I don't have the actual numerical angle measure. I don't have an actual number in degrees that tells me how big these angles are. I do know that this angle and this angle are congruent because they have the same Kirby hash mark. And this angle and this angle are congruent because they have the same Kirby hash mark. So again, these triangles are similar because of the angle, angle, similarity statement here. Two pairs of angles are congruent. And finally, the last way that we can answer the question, how do you know if two triangles are similar, is if two pairs of sides are proportional and the included angles are congruent. So now we have this statement that is going to let us say that two triangles are similar if I have not three pairs of sides, but only two pairs of sides that are proportional. These two pairs and this pair and this pair. And the included angle. Now when I say included angle, included means included between the two sides that I'm looking at. So for example, this side and this side, this angle right here is included in between those two sides, and this angle is included in between these two sides. So if these two pairs of sides are proportional and I've got their included angles congruent, then I know these triangles are similar. And in fact, I already know that these two pairs of sides are proportional because these are the same measurements we've been looking at in the previous example. So 5 over 35 is 1/7. 6 over 40 is 1/7. So since these two are equal, then I know that two pairs of sides are proportional and the included angles are congruent. Therefore, these two pairs of triangles are similar. So I can say these triangles are similar because, and again, I could write out this whole statement. These triangles are similar because two pairs of sides are proportional and the included angles are congruent. Again, there's a shorthand notation that we can use for this answer, and it is usually written like this: side, angle, side, and again, the little similarity symbol. And so when I want to say that two triangles are congruent, when I want to say that two triangles are similar because I have two pairs of proportional sides and the included angles congruent, then I could just use this as my shorthand way of answering that question. So these triangles are similar because of the side, angle, side similarity statement, which is this statement right here. Now, these two triangles here, at first glance, it may look like, well, aren't these, isn't this exactly the same picture that I've got right here? Except it's not exactly the same. Notice that even though this pair of sides and this pair of sides are proportional because they're both equal to the same number, notice that this angle right here is not the included angle. This angle, in other words, is not included in between these two sides. If it were, it would be down here, be in that angle. So since that angle is not included between these two sides, I can't use the side, angle, side similarity statement. So these triangles I know are not congruent, and actually my answer here would actually be a little bit longer. These triangles are not similar because, well, I can't use the side, angle, side similarity statement. So I would say side, angle, side similarity does not apply. And it turns out my answer number 4, which is the angle-angle similarity statement, well, that one also does not apply. And I can see the angle-angle similarity statement doesn't apply because I don't have two pairs of angles that are congruent. I just have this one pair of angles here, so that doesn't apply. Also, I notice the side, side, side similarity statement, which is my answer number 3. Well, I can't use that one either because I don't have 3 sides on this triangle that are proportional to 3 sides on this triangle. So this one also does not apply. And I notice I can't use answers number 1 or number 2 either because neither one of those applies. So these two triangles are not similar because none of these answers that I've looked at before applies.